Oh, this is cool. Another maths exercise. All right, this is exercise 9J, and this one is important, as they all are. So this one is the product rule. Yep. So it says, in the next two sections, we're going to be learning some more rules for differentiation. Cool. This one is the product rule. Now, what you do need to know is if you have a function such as f of x and it's multiplied by another function such as g of x, and you can calculate the derivative of f of x and the derivative of g of x, and they exist, then you can calculate the derivative of that product function by multiplying the original f of x function by the derivative of the g of x function, so the first function multiplied by the derivative of the second function, plus the second function, g of x, multiplied by the derivative of the first function, derivative of f of x, which is f dashed x. Yep. Now, as it alludes to up here, if you had these two functions and they were multiplied by each other and you wanted to differentiate that, yeah, you could have multiplied them together first of all and then differentiated them. However, that's alright if you've got simple functions like that, but some of them are more complicated and this rule makes life a lot easier. So definitely this one gets put into your fun booklet. Absolutely. Again, if you desperately want to know how all this is comes about, happy for you to read the proof there. The notation, another notation as well that you'll find being used is Leibniz's notation. So if you have y equals uv, so where u is a function and v is a function, they're multiplied by each other, so they're getting the product of the two functions, then you could write it out as the derivative so dy dx is equal to this function u multiplied by the derivative of this, which is dv dx, plus the second function, which is v, multiplied by the derivative of this, which is du dx. Yep. So it's same thing. It doesn't matter which notation you use, whether you use this or the previous one. Ultimately, you're still doing the same thing. The first function multiplied by the derivative of the second function, plus the second function multiplied by the derivative of the first function. Yep. Cool. Let's see this in action. Oh, cool. We've got two functions multiplied by each other. Yep. So right here you've got a function, and right here you've got a right here you've got a function. They are multiplied by each other. So we can use the product rule, which we're learning about right now. So again, you could write out the question. Check. From there, making the first function equal to u. So u is 2x squared plus 1, and here the second function they're calling v, so they're using Leibniz's notation for this one. Yep. So v is 5x cubed plus 16. Cool. Working out the derivative of each of these. Yep. So du dx is obviously 4. The 2 times 2 is 4. Take away 1 from the power, so it's 4x. Here, 3 times 5 is the 15. Take away 1 from the power, so it's 15x squared. That becomes 0. Yep, so we've got the derivatives of each of those. Notice they're carefully writing out each of these bits. Then, I would recommend you carefully write out the product rule. So dyex is equal to u multiplied by dv dx plus v multiplied by du dx. We've got each of these parts, it's just a matter of now substituting them in. Yep. So we had u was 2x squared plus 1 multiplied by dv dx, which is 15x squared, plus v, which is 5x cubed plus 16 multiplied by derivative of u, which is du dx, which is 4x. Yep. From here it's a matter of multiplying things out and simplifying things down. That's meant to be a check. We'll turn it into a happy face. Cool. Alrighty. Next. Cool. Same difference. You've got a function here, which is x cubed. You've got another function, which is, so it's multiplied by another function which is 3x take away 5 to the power of 4. Yep. So, oh, what am I doing there? That's a function there. Yep. So writing them out, u is x cubed and v is 3x take away 5 to the power of 4. So you do need, whoops, daisy. You will then need to get the derivative of each of these. So derivative of u dx is 3x squared, and the derivative of v. Now in this particular case, remember you're going to have to use your you go to your maths toolbox and pull out things on how to differentiate. Remember this here, you're going to have to use a chain rule. That's the same as u there to the power of 4. Wow. Whoa. Imagine I'm writing u to the power of 4. Yep. So you're going to have to use the chain rule to do that part of the differentiation. Yep. But you guys have learnt that, so it's okay. Yep. Writing out the product rule, substituting in each of the parts, and then simplifying things down. Again, please be careful not to make mistakes when you're doing this here. Let's have a look at this one. Oh, cool. Again, we've got a function multiplied by another function. Again, write them out carefully. This time they're using the notation with f of x and g of x. Yep. So again, f of x, you listed it. The second function we're calling g of x. Working out f dashed x, so the derivative of this. Working out the derivative of g of x, g dashed x. Again, that's the same as u cubed. Yep. So you're going to have to use a chain rule on just even that part to get the derivative. But you can do it. I believe in you guys. Yep. From there, writing out the product rule, which is the original function, f of x multiplied by the derivative of the second function, plus the second function, g of x multiplied by the derivative of the first function. Yep, so they've written it out. From there, it's a matter of simplifying things down, writing things with positive powers, putting all the skills into practice that we've learned. Yep. Example 35 says differentiate each of these with respect to x. Cool. So again, you've got a function here, e to the power of x, and the other function, it's multiplied by 2x squared plus 1. So there are your two functions. Right, I would still write out, this one's u, this one's v, if that's the notation you want to use. Again, you need to, it'll be the derivative of this here, which is x, it's the same, e to the power of x, multiplied by the second function, yep, plus the derivative of this, which is 4x multiplied by the original function, which was e to the power of x, yep. Again, simplifying things down from there. Here we've got one of the functions still e to the power of x. The other function is the square root of x take away 1. Remember, that is the same as, in brackets, x take away 1 to the power of a half. And given that, to work out the derivative of that part, you will have to use the chain rule. Yep. So I'd write out, obviously, this function, the derivative of e to the x is still just e to the x. Write out this here, whether you use, it might be v, calculate dv dx, the derivative of that, and then write out the product rule and carefully work through each of those steps there. We just did trigonomic derivatives like not long ago. So again, this should be pretty fresh in your mind. Yep. See a function, 2x squared, it's multiplied by another function, which is sine 2x. Again, straight away, two functions multiplied by each other, product rule in your head. Yep. So I'd actually write down what each of these is. U as being 2x squared, v as being sine 2x. Write out the derivative of each of those. Plug them into the product rule, and then you can go from there. Yeah. I believe you should be able to carefully have a look through these, identify the two functions. One's obviously e to the power of 2x, the other one's sine 2x plus 1. Working out the derivatives of each of those, putting them into product rule, working through it. Likewise here, you got two trigonomic equations that need to be differentiated. Cosine 4x and sine 2x, working out the derivatives of each of those, plugging them into the product rule. Yep. Pretty fun exercise in my opinion. It takes time, you need to be careful with it, but it's achievable. Yep. I would be definitely making a note of the product rule in your notes. Whether you prefer this notation or Leibniz's notation, it does the same thing. Yep. Definitely go and put this in your fun summary notes. Thank you very much for listening. You do have a bit of maths to do today. Bye for now.